Welcome back. We're going to be talking about graphing a function rule. So this kind of builds off what we've been doing over the last couple weeks with looking at rates of change, our starting point. But this time we're going to actually create and graph these out, looking at what they are. So before we were trying to find a rule, now we're going to be given a rule, like we have here, y equals 3x minus 1, and then graphing it, seeing what this actually looks like. So the couple things I want you to anticipate. I want you to anticipate or predict, that's actually a better word, predict what our rate of change is and what where we're going to start. Now for any equation, and this goes for, right now we're going to focus on linear equations, but this goes for anything. Anything we can put in and write as a function. Whenever in doubt, we pick some numbers for x, plug them in, and you get a y value, and create an xy chart. We can then plot those points, and we can connect our dots with either a smooth curve or a line, depending on what kind of graph it is. So the first one, we have y equals 3x minus 1. Now looking at this, again, I'm going to predict that my rate of change is 3. Remember, that's where we put our rate of change in our equation. Our starting number was this number here, negative 1. So let's see how that works out when we start plugging these numbers in. So everything stays the same from this part except the x gets substituted. So, and I always start with negative 2, negative 1, 0, 1, and 2, generally when we first start graphing these. So I'm going to plug these numbers in where the x is. And I'm going to multiply this out. If you have a calculator, you want to calculate it out, you can. So I have 3 times negative 2, which is negative 6. Negative 6 minus 1 is negative 7. I put negative 1 in here. 3 times negative 1 is negative 3. Minus negative 1 is, or minus 1 is negative 4. I plug 0 in here. 0 is a great number, because anything times 0 is 0. 0 minus 1 is negative 1. Put a 1 in. 3 times 1 is 3. 3 minus 1 is 2. Put a 2 in here. 3 times 2 is 6. 6 minus 1 is 5. And I have my numbers. I now have what we started with before. And look what we have. What is the pattern that we have? Each time we are going up by 3 units. And I'm going to put a box around my start. Remember, what the start is where the x is 0. Look what my start is. 0, comma, negative 1, and there's my negative 1. So my chart matches up with what I predicted. I can now plot these points. These points are now, move this over. So the points I have are 2, negative 7, negative 1, negative 4, 0, negative 1, 1, comma 2, and 2, comma 5. There's our points. Now what we can do, we can now plot these points on a graph. Now hopefully you have graph paper, but if not, you kind of have to do the best you can. So I have negative 2, negative 7. Here's my first point. Negative 1, negative 4. 0, negative 1, 1, and 2, and then 2, and 5. Now if you look, these points somewhat make a straight line, and we can connect our graph with a straight line. These are all linear functions, so they should make a straight line. Just like that. So now we're going to look at number 2. I'm going to leave these points here of x's. Okay. And the function this time is going to be negative 2x plus 5. So I'm going to be substituting all these numbers in, and so forth. And you're going to continue down doing this. If you notice, the only thing that changes is that x value. So again, I'm going to predict this. My prediction is that my rate of change, I'm going to be reducing by 2 every time. And my starting number is going to be 5. So I'm hoping that a 5 comes up right here. So I'm going to do this a little bit quicker. This ends up being 9. This ends up being 7. This one is 5. This is 3. And this one is 1. There's my prediction. I'm still going down by 2. And again, my number here is, my starting number was 5. So I have different points here. So my first point is negative 2, positive 9, negative 1, 7, 0, 5, 1, 3, and 2, 1. Again, these should make a straight line. Negative 2 and positive 9. So kind of way up there with my first point. Negative 1 and 7. 0 and 5. 1 and 3. 2 and 1. And there's my line. I know it's not perfect on the graph, but again, at this point, we're just sketching them, especially since I'm freehanding them. So there's a fraction one there. We will work on that one in class, but you can go ahead and try it. And again, your change, anticipate what the change is. It's 1/2 x plus 3. So we're going to be going up a half a unit each time. And our starting point is going to be 3. So again, come back here, and we can always do an XY chart. We're just plugging numbers in. The second part of this lesson is talking about whether a graph is continuous or discrete. Continuous. A continuous graph, it's a graph, I think I put it on your papers, that is not broken. It continues on forever. There's no breaks in it. I can take my marker and I can draw any kind of curve and it's going to keep going on. I just graph that whole thing without taking my marker off the page. That is a continuous graph. There's no breaks in it. Whereas something that is discrete has breaks in it. A discrete function is made up of isolated points. So a discrete function might look like this. Notice how I'm taking my marker off the page all the time. Individual points, just like that. We saw some discrete functions earlier in our textbook that might look like this. Point there, point there, point there. And it looks like it's making a curve, but it was not connected with a curve. So a discrete function is isolated points. Now, where does this come into play? Let's think about some examples of what would be continuous and what would be discrete. We'll start with continuous to start off with. So I listed a couple of them. Examples of continuous graphs. And these are in your notes. Right. Continuous. How much you pay for gas. So right now I think it's $2.69 a gallon in a lot of places. Now the reason why it's continuous is because I can buy different fractions of gasoline. I can buy 17.4 gallons. I can buy 3.1 gallons. I can buy 10 gallons. I can buy all these different increments. They come in, how we purchase gas at the gas pump is, it just flows out. When you're pumping gas, it's continuously running out. And you see the price keep going up and up. The amount of earnings you work at McDonald's, okay, is continuous. It's an hourly wage. So any hourly wages, you're paid continuously. If you're getting paid $10 an hour, right? You don't just once you work an hour, it doesn't go up to $10, but you're getting paid as it kind of, the more you work, the more you get paid. How you grow, you don't automatically grow like 3 inches when you wake up on your 15th birthday. All of a sudden you go from 5'9" to 6 foot. You're continuously growing, even though we don't see it. Okay, it goes on forever. And then distance home. Distance is always continuous. Some things that are not continuous. Maybe the amount of money you pay for each cell phone you own. Okay? So again, maybe your family, you want to buy brand new phones for everyone for Christmas. And maybe each cell phone is $700. Now, what makes this different is, can you buy half of a phone? This is a big thing to decide. Can you buy half of a phone? No. You can buy one phone. You can buy 2 phones. You can buy 3 phones. You can buy 4 phones. So if we were to graph this, 1, 2, 3, 4, there's your discrete function. Isolated points. Another example is the amount of sick time you might use in your job. I can't take 2.5 hours off of work and get paid for it, or use that as sick time. Here at school, we're allowed to take half days, half-day increments. I can't just say I'm taking off this period, or I want to skip 5th period and go out for a long lunch, or either take the whole day off or half a day off. I can't just say, hey, I want 2.5 or 0.57 days off. Earnings from the amount of garbage cans sold at a hardware store. Again, we cannot sell 3.2 garbage cans. I can sell 3 garbage cans, or I can sell 4 garbage cans. I can't sell a fraction of them. And the other one is, how many students are passing a class? Hopefully all 20 of my students pass the class. But I can't have 3.5 students not passing, or 16.475 kids passing. It's either 16 kids or 17 kids. It's one or the other. That's why we call it discrete. That's where we get these points. So over the next couple of days, I'll be giving you some more examples of this. But think about the difference is, can you write this as a fraction? If you cannot write this as a fraction, or take a fraction of it, if you can't take a fraction of it, it is discrete. See you next time.